parallel computing. But with photons, like it is greater maybe two parts sent to the same device, because these photons do not interact with each other. You can do parallel processing very easily. You can have speed, the ultimate speed is possible. The speed of electrons is typically of the order of like 10 power 5 meters per second. But in terms of photons, like you can have like 10 power speed of light. So you can have like large storage density. We talk about like fluid disk and all. Okay. So you get like enormous amount of storage capacity to use photons. And I mentioned like minimal crosstalk and interference. These are the huge advantages to potential of operation compared to our things like this. So if you want to imagine that the first thing which we need is like, okay, photons will be better than electrons. We can use it, but the electronics industry is so huge, enormous. Like they are like the automobile industry. They don't want us to use public transport. Everybody, like every car maker, like offering so many freebies. Like, oh, buy our car, like you get like 21 miles per liter or something like that, 21 kilometers. Okay. So they want us to buy our own car rather than using a more efficient like railway system or a public city bus. Similarly, like in electronics is huge industry. To compete with it, we have to think of a practical solution which is like very cost effective and which is really easy. For that, first we have to start with some dream. The dream is we want to make an optical integrated circuit, like an electronic integrated circuit. I want to make an optical integrated circuit. What are all the things required? Okay. So first thing is I want to couple light from my say fiber to some integrated circuit which looks like this. So this is my coupler. And then these blue things and these brown things, these are essentially gold colored things, these are essentially three-dimensional structures in which we process. For example, like a transistor. So this is like a device. Okay. A diode or rectifier device or a transistor or anything. And then like I need to, like for example, I want to add 1 plus 1 and then multiply it with 1. Okay. So the addition can be done in this 1 plus 1. So the two output comes. Okay. So which has to be coupled with a multiplier. Okay. So how do you do? Like you need to couple light from one device to the other. So you use these two-dimensional structures, which are essentially as shown here. This can be like rods standing in the air. Okay. So this essentially couples light from one device to the other. And then within the circuit, like you can have these outer one-dimensional structures where it's like the waveguides, okay, where like light can be transmitted from one part of the circuit to the other. So this is imagination. This is cover from this is from the cover of a book called Photonics okay. So this can be used for future quantum stuff like electrons. You have like many electrons. You measure the current, milliamp, picoamp, whatever. But it's just like millions of electrons. But eventually, you want to have security, and that like people are talking about using single photons. You have a photon or you don't have a photon. So, for example, you are sending your information, your message to say your girlfriend. So you don't want your parents to read. But your parents can always, if you're using light, you can always put a beam splitter, so just a glass piece. Okay. It reflects some of the photons. Okay. And if I know like what is the code in which like you are encoding your signal, okay, I can always steal your message. But if you have a single photon, and if I put you are sending a single photon, either photon is there or not. Now if you put a mirror and if I steal that single photon, then your receiver knows, oh, I have not received any signal. So then you immediately know that like somebody is stealing your data. So it gives like very high security for communication. Similarly, like you can have quantum computing because of the parallel nature. So this is an artist